In this video, we're going to have a look at how to calculate the total surface area of a composite 3D shape. Having a look at the question, it says that a cylindrical plastic vase is 66 centimeters high and has a radius of 12 centimeters. The center has been hollowed out, so there is a cylindrical space with a radius of 9 centimeters and goes to a depth of 48 centimeters. And at the end of that cylindrical space is a hemisphere, which is shown in the diagram. Now the question is asking us to complete two calculations. The first is the area of the external surface of the vase. The second is the area of the internal surface of the vase. Now we'll complete each of those calculations separately, starting with part A, which is the surface area of the external surface of the vase. Now to complete that, we are going to draw a net of the shapes that make up the external area of the vase. And the first shape we're going to start with is the circular base down the bottom of the vase. So moving up from the circular base, we have got our side of the cylinder. Now the external side of the cylinder, when we flatten it out, is going to be in the shape of a rectangle. So we're going to add a rectangle into our net that joins on to our circular base. Now that we've got the base and the side of the vase, we need to have a look at the top. And the top is again a circular top. So we're going to add in our circular top. But this time, it is not a complete circular top because it has the hollowed out part in the middle. So we need to add in another circle that hollows out part of our circular top. So now we have the net for the external surface area of our vase. Before we can go ahead and complete our calculations, we need to go ahead and add in some measurements. So starting with the circle at the bottom of my vase, it has a radius of 12 centimeters. The side of the vase has a height of 66 centimeters. And the two circles that form the top part of the vase, the outer radius is going to be 12 centimeters. The inner radius is going to be 9 centimeters. So that is all the measurements I need to go ahead and complete my calculations. And to enable me to help with my setting out, I'm going to label each of my shapes. So the circle at the base is going to be shape A. The rectangular side of the cylinder is going to be shape B. The outer circle at the top is going to be equal to shape A, and the inner circle that is hollowed out is going to be shape C. So my next step is to go ahead and calculate the individual area of shapes A, B, and C. So area of A, and that shape is a circle, so my area is going to be pi times radius squared. Substituting into my formula, pi times 12 squared, which equals to 452.39 centimeters squared. So I will add that into my net. So 452.39 centimeters squared. Area of shape B. Now that is a rectangle, which I know the width, but I haven't been able to calculate the length. So I'm going to use part of my total surface area formula of a cylinder to be able to calculate the area. So, and that part is going to be 2 pi times radius times height. Now 2 times pi times radius is going to calculate the circumference of the circle down the bottom, which is also the length of the rectangular side of the cylinder. So substituting in my values, 2 times pi times 12 times by 66, which is my height, is going to equal 4,976.28 centimeters squared. So adding that into my net, 4,976.28 centimeters squared. And the last area I need to calculate, area of C, which is the hollowed part of the top of this vase. So the formula is going to be pi times radius squared equals pi times 9 squared, which is equal to 254.47. So adding that into my net, 254.47 centimeters squared. So now I've got all of the individual areas I need. I can proceed to calculate the total surface area of the external surface of the vase. So the total surface area of the external surface of my vase is going to be equal to the area of shape A plus the area of shape B plus the area of shape A, but this time I'm going to subtract the area of shape C, because shape C, remember, is the hollow part of the top of the vase that doesn't form part of the external surface. So substituting in my values, it is going to equal 452.39 plus 4,976.28 plus 452.39, subtract 254.74. So completing that on your calculator, the total surface area is going to equal 5,626.59 centimeters squared. And because the question asks us to round to the nearest centimeter, that is going to equal 5,627 centimeters squared. So the total surface area of the external surfaces of my vase is 5,627 centimeters squared. So now we can move on to part B, and that is to calculate the area of the internal surface of the vase, and we're going to follow a similar process. We are going to draw a net that breaks down the shapes into its individual 2D shapes and then add them together to find the total surface area. So having a look at the internal surfaces of my vase, I have a cylinder that doesn't have a top or a bottom. So I've just got the curved side of the cylinder, which when flattened out is a rectangle. So I'm going to start off with a rectangle. The second part of the internal surface is going to be a hemisphere or half a sphere. So that is the second shape I need to add into my net. So now that I have my two shapes, I can go ahead and add in the measurements that I need. Now the height of the cylinder is going to be 48 centimeters. And the radius of my hemisphere is going to be 9 centimeters. So now I can go ahead and calculate the area of each of those surfaces and then add them together to find the area of the internal surface of the vase. So I will label them shape A and shape B. So the area of A, which is the curved side of the cylinder, so I can use 2 times pi times radius times height. So substituting in my values is going to be 2 times pi times 9 times 48, which is equal to 2,714.34. So adding that into my net, 2,714.34 centimeters squared. And then I can go ahead and calculate the area of B, which is a hemisphere or half a sphere. I can use the total surface area of a sphere being 4 times pi times radius squared. And then because it is a hemisphere, I divide it by 2. So substituting in my values, so 4 times pi times 9 squared, divide by 2, equals 508.94 centimeters squared. So again, adding that measurement into my diagram of my net, 508.94 centimeters squared. So now I can calculate the total surface area of the internal surfaces of the vase by adding my two surfaces together. So total surface area equals area of A plus area of B. So substituting in my values, it is going to be 2,714.34 plus 508.94. So that equals 3,223.27 centimeters squared. Rounding to 2 decimal places, it's going to be 3,223 centimeters squared. So the total surface area of the internal surfaces of the vase is going to be 3,223 centimeters squared. So those are some examples of how we can calculate the total surface area of composite 3D objects by drawing a net, calculating the individual area of each of those shapes that make up the net, and then adding those areas together to get total surface area.